Hello. Let's start with this. Who am I? Well, that's not very interesting, right? But maybe a more interesting variant of that question is, who am I to lecture you today about source and binary compatibility? And I chose the word lecture very specifically because it might feel like a lecture. Especially it might clash with a few things that were said this morning about, source dependencies and stuff like that. You will have an idea of what is my position on that kind of stuff. So the answer to that question is, well, I'm the author of ScalaJS. And why is that even relevant to the topic of today, which is binary and source compatibility, which seems to be like more about the JVM stuff than JavaScript? What does it even mean for binary compatibility in JavaScript? So the thing is that ScalaJS is this thing which has been backwards binary compatible in the 06X branch since 060, which was released more than 3 years ago. So the ScalaJS ecosystem of 06X, we managed to keep it completely backwards binary compatible for more than 3 years. And that's actually, it comes a close second in the longest streak of binary compatibility in the Scala ecosystem. The first is actually SBT013, who has a few more months of keeping binary compatibility. So it's a lot of experience that I've gathered about how we can do these things. And second, as developer of ScalaJS specifically, I also have a kind of unique experience on all the details of how you compile Scala, which means I actually have a lot of knowledge about the internals that cause these things. OK, that's enough. Let's go into part 1. So first question, what is source compatibility? What is binary compatibility? What is forward-backwards compatibility? You might have heard of these terms. But after all, what is compatibility? Right. So compatibility is, I have some A, some B, and some X. They don't even have to be software components. They can be stuff, right? And at some point in time, the stuff X uses A. And at some later point in time, the stuff X has stopped using A and is using B instead. And does X keep working? If it keeps working, for some definition of working, then we can say that B was compatible with A or vice versa. So this is compatibility. I can take two things, I can swap one for the other, and other stuff keeps working. OK, let's dive a little bit more into the software component and specifically libraries kind of stuff. So typically, when we talk about compatibility of libraries, we think about several versions of the library. So I have a version v1 of A and then a version v2 of A. And if I can replace a v1 by a v2, we say that a v2 was backwards compatible with respect to a version 1. So backwards because v2 can still do all the things that its backwards version v1 could do, so it's backwards compatibility. We can also swap them around and say, if it worked with v2, and I replaced v2 by v1, does X still work? That sounds weird, right? So this is what we mean by forward compatibility. Note that here I haven't even talked about source or binary, right? I'm still only talking about compatibility. So let's talk about source and binary. So I have a version 1 of A with a class foo that defines the method bar, taking an int, returning an int, doing x+1, easy. And then I have a second version of A where I change the ints to doubles. So from this point in time, I'm only going to talk about backwards compatibility. Whether it's be source or binary, I'm only talking about backwards, because that's what we think most of the time. And if you want forward, it's easy. You just swap out the two versions, and you get the definition of forward compatibility. Okay, so let's do a show of hands. Who thinks that this change is backwards source compatible? Okay. Oh, there is one. Who thinks it's not backwards source compatible? Most people, and you are right. Of course, because I could have changed this call to bar, receive a y, and put it in an int, and the new code would not compile anymore. Who thinks it's backwards binary compatible? No, backwards source, not backward binary compatible? Good. Okay, you're following. So this is clearly wrong, right? Okay, let's take a more tricky example. I have a class. I haven't changed the signature of bar. I have changed its body, but its body is fine, right? But I have introduced a private field in there. Who thinks that's backward source compatible? Who thinks it's not backward source compatible? Good. Who thinks it's backwards binary compatible? Not that many. Who think it's not backwards binary compatible? A few people. Well, the few people, sorry, you are wrong. So this one is actually backwards source and binary compatibility. Backward compatible. Because fields on the JVM, you can add a private field in the class, and it will be hidden by the JVM. It's going to be fine. Did you notice the tiny change right there? The trait. So, backwards source compatible. Not backwards source compatible. Good. Backwards binary compatible. 5 or 6 people. Not backwards binary compatible. A large majority of you. And you are right. So this is a backwards source compatible change, because yeah, sure. I mean, my new trait foo, it has a private field now. I can recompile against this thing. It's fine. However, it's not binary backwards compatible. Why? Because if I extend that trait with a class bar in a separate library, the Scala compiler needs to take that field from foo and create a field in the class that mixes in the trait. So we'll see that a bit more in detail later, but yeah. This one is fun. So I have a class foo, it still has that method bar, and then in the version 2, I add another method in that class. Who thinks that's backwards source compatible? Almost everyone. Who thinks it's not backwards source compatible? A few people. Backwards binary compatible? Oh, half of you. Not backwards binary compatible? A few people. So, hold on to something. This is a backwards binary compatible change, but it's not source compatible. So did you see what I did there? I added a public method to a class, right? I can even make that class final. It won't change the results of this poll. Even with a final class foo, I add a public method in a final class. That's not source compatible. So how many of you have ever released a new version of a library that had one more public method somewhere, and you said it's backwards source compatible with the previous one? Well, sorry, you lied. Yeah. So that's on the next slide. So why is it not backward source compatible? Well, because some guy somewhere could have had that implicit class in his code. He could have pimped the method foobar on top of your foo, and then use that thing. So if you now introduce the same foobar in your class foo, but it does a different thing, when the guy recompiles their code starts doing something differently. It's silent. However, if they don't recompile, they use the old binaries, they will still link to foo ops to their implicit class. So this is a backwards binary compatible change, but it's not backwards source compatible. And unfortunately, that's not a theoretical issue. It has happened in the history of Scala, major problems when Java added a method in the public API that a large body of Scala codes kind of broke to some degree because it relied on some implicit class on top of the Java thing, and then the Java thing started providing the same method, except it was not quite the same method. So, meh. Okay, so let's think about when does compatibility matter? Let's say I'm writing an application X, and I have XV1 and then XV2. Well, nobody is using my stuff. I mean, maybe they use the UI or the command line interface, but not the API of that thing. So it's neither source nor binary compatible. I mean, you can break source or binary compatibility. It won't affect anyone, right? Let's say you write a library A that is used by an application X. Well, at some point in time, X is compiled against V1 and uses V1. So that's fine. And then at some point, X might decide to upgrade to V2. But at that very moment, it will recompile against V2 as well, and then run against V2 as well. So the only thing you worry about in this scenario is source compatibility. However, if you start having transitive dependencies, then at this point in time, X depends on B and C, which both depend on AV1. But then at some point, the next version of C starts depending on AV2. And then X wants to use the new version of C, and then suddenly it needs AV1 and AV2. So of course, your dependency manager will pick AV2 because it's smart. But at this point, if AV2 is not binary compatible, backwards binary compatible with V1, then things break, right? So source compatibility matters here for your direct dependent, which is C, but binary compatibility matters for your transitive dependence. So that's a small thing. What if you have this? So you're the maintainer of AV1, which is colored in blue in there, and this is the Scala ecosystem. It's actually a very small part of the Scala ecosystem. So who is under threat of source incompatible changes? Well, the direct dependents, J and K. Who is under threat of binary compatibility problems? All the ones that transitively depend on these things. So it's a lot more libraries and programs, right? But even worse, at the moment where K decides to upgrade to AV2, I have a significant portion of these things who depend both on J and K, who suddenly are under direct conflict. Suppose V2 is not backwards binary compatible with V1, all the libraries in red cannot upgrade. They cannot upgrade to the new version of K. It's literally impossible. So this is worse than dependency hell. Dependency hell is when you have to upgrade so many things at the same time that you don't know where to start. But this is even worse. There is no way you can upgrade to the new version of K. So if the new version of K fixes a critical bug for you, you're completely stuck, right? So this is something that never happens with source incompatibilities, because it's only at one specific library you decide at one point I upgrade to that other one, I fix the compile errors, it links again, it works. But the binary problems, they trickle down through the entire ecosystem, and they're not fixable. So you enter in a complete lockdown. So to give you an idea, and if you remember the keynote from this morning, guess where Scala.js is on this graph? It's right there at the top, that B thing. So every time we break something, it's like the entire ecosystem is dead. So of course, you can imagine that we do everything we can for that not to happen. OK, so I hope now I have convinced you of the importance of binary compatibility. And I also hope kind of that I have convinced you of the relative non-importance of source compatibility. Source compatibility is completely overrated. And consequently, source dependencies are completely overrated. And you actually don't want to have an ecosystem that builds on source dependencies, because it's impossible to evolve a library in source-compatible ways in Scala. You add a public member, and you break source compatibility. So if you want to preserve source compatibility for your library, it's very easy. You don't change it, right? Or possibly you fix a bug inside the method, but that's all you can do, literally. OK, so summary so far. Binary compatibility, it's hard to get right. And when broken, it's disastrous for the ecosystem. Source compatibility, well, it's virtually impossible to achieve. And when broken, it's inconvenient for your direct dependence, but not so much for the ecosystem. So that leads to a versioning scheme. When you break source compatibility, it's a bit inconvenient, but it's no big deal. That's a minor version bump. You break binary compatibility, you're breaking the entire ecosystem that depends on you. That's a major version bump. And if you're in 0x, you can shift things one level, right? But yeah, that's basically it. This is probably the biggest takeaway of this talk. The next time you publish a library, think about this. Like, seriously, source compatibility is not that big of a deal. You have to take care of binary compatibility first. Part 2, or when, or how to actually preserve binary compatibility. So, oh yeah, if you wanted me to give you advice on how to preserve source compatibility, I just said that a few seconds ago. It's easy. What do? Don't change it. So, to avoid binary incompatibilities, one essential tool, MIMA, which stands for Migration Manager. This thing is a little jewel. It will tell you, hey, the change you just did right there in your PR, it's actually breaking binary compatibility for that method, or for that class because it's final and it wasn't before, or stuff like this. Or you added a method to a trait, which is also a binary incompatible change, and stuff like this. But sometimes when you do stuff, you will realize that ScalaC also generates public members for stuff that MIMA will complain to you about. But at the same time, you know, at least from Scala code, I cannot call these things because it's really private from Scala's point of view. It's just that to encode it on the JVM, it has to make it public. So then MIMA complains, but at the same time, it's not a big deal. So you can tell MIMA, ignore that one. But this is tricky. It requires a lot of experience. It requires kind of a lot of knowledge. And it's so tricky that ScalaC people get it wrong sometimes. If you remember 2.11.9, well, if you don't remember, that's because it was hidden under the carpet because they broke binary compatibility with the wrong filter. So, oh yeah, source compatibility, yeah, don't change it. OK, But the thing is, so MIMA is really great because it will prevent you from doing a mistake after the fact. In the sense that you've already published V1 and you're working on V2, and it will tell you, oh, that changed, you're not allowed to do it because that would break binary compatibility. But at this point, if you wanted to make that change, you're like, what do I do now? So MIMA is good to prevent you from doing mistakes, but it's not good at helping you designing your library up front so that you will be able to make changes later. So this is what we're going to focus on the second part of the talk. There is one thing that you need to use for that, and I'm sorry, you have to learn the compilation scheme. Like at some point, you have to have a sufficiently good idea of what Scala constructs will produce what kind of JVM signatures. Because, yeah, if you're serious about binary compatibility in your libraries, this is the only way to really get it right. So one tool for that is use the xprint mixin option to ScalaC, because it will print you a Scala code that looks very much like what it will emit at the JVM level. So it's still understandable for us Scala programmers and not for JVM hackers. But at the same time, it's really close to what it means for the JVM. So let's take one example, default parameters. So in case you didn't know, if you have a method foo with default parameters, what you get on the JVM is more like the second half of the thing, which is you have one method which takes all the parameters as mandatory on the JVM, obviously, and then you have those two synthetic weird things that are called foo $default $2. Why 2? Because it's the second parameter, right? And then at the call site, if you called foo with 3 and 4, on the JVM thing, you receive an additional parameter, which is explicitly calling that foo $default $3, because it's the third parameter. So what does that have as consequence? Well, the consequence is that if you add a fourth parameter, well, then the signature of foo at the JVM level goes from 3 to 4 parameters. And that's not the same method anymore. So you removed the old method from the JVM's point of view, and you added a new one. So obviously, that's not binary compatible. So adding a parameter, even with the default value at the source level, is actually completely breaking at the binary level. So basically, don't use default parameters. What if it's too late and you've already published V1 and you did use default parameters? Well, you can recover from it, kind of. Deprecate the old one, keep it exactly as before, introduce a new one that doesn't have default parameters and that has more parameters, and then you will be fine. But at the same time, it's not really cool to keep adding new parameters and deprecate methods with fewer parameters as you go. So typically, you would actually use an option bag if you ever expect that list of parameters to grow. And typically, if you have default parameters, it means those parameters really are options, and they should be in an option bag for future evolution. So how do you do option bags? With a case class, with default parameters in the signature? Well, if you do that, then you end up with this thing at the binary level. Doesn't feel really good, huh? So basically, don't use case classes. If you did use case classes, how do you recover? Well, it's tricky. You basically have to take that thing from the JVM point of view and put it back in the source codes and deprecate everything and then turn it into a non-case class. And it's ugly. As the SBT guys, they did that a lot in SBT 013. Yeah, you don't want to do that. So I repeat, don't use case classes. So what do you do for option bags? Well, this is what you do. You have a foo options, which is a final class. It has a private constructor. It has val parameters, that we will be able to read. It has a private constructor that takes no argument and then constructs an instance with all the default values. And then you have those copy-paste error there. With X and with Y should be public. That's the whole point of it. So these are the two public methods that create a new foo options with one of the parameters that have been changed. And they rely on a private def copy that has default parameters just for boilerplate, but it's private. And then you implement toString, and you implement equals, and you implement hashcode by hand. Or you use code generation to do that, but to generate that. And that's also what the SBT guys do in 1x now with their contraband tool. So you might want to use contraband. Personally, I think that this is less boilerplate than the JSON file of contraband. So I don't use contraband, but it's your call. Okay, so I mean, why do we even have case classes then in Scala? Well, case classes, they're case classes. The whole point is if you intend to use them in a case class of pattern matching. If you do that, fine, it's a case class. But remember, it's frozen for eternity. You cannot change it. Yep. I'm coming to that. So if you have case classes, you intend to pattern match on them, by all means, do use a case class. But remember, it's frozen for eternity. Oh, and yeah, make them final, because they're not final by default. Yeah, it's a bit later. It arrives at some point. Open traits. So open traits as in non-sealed and non-final. Remember that private field in the trait, it's here, private var. And if you look at the generated code for tests, it doesn't have a field, actually. It has two defs, a getter and a setter. And the class that apparently just mixes in tests actually does a lot of things. It declares the actual field, and then it implements the accessors to read and write set field. And even funnier, it actually does implement foo as well, even though it was concrete here. And this is Scala 2.12, which uses default methods. But you know, since the JVM is not good enough at dealing with default methods for performance, Scala C will actually create that bridge in addition. So it will be binary compatible to add a method in 2.12, but it won't get the same level of performance. And you have to keep that in mind in some weird cases. So basically, don't do open traits. Seal them. Always, or make them final, but the final traits, no, so seal them. Or you make sure that they really are completely abstract interfaces in the sense of Java, because they're meant to be implemented by some people outside of your API, of your library, but then really keep it completely abstract, just abstract defs. Possibly in future versions add concrete. If you only target 2.12 and later, you can add concrete methods, it will be fine. But certainly don't put fields in them if they're meant to be open. Oh, yeah, I don't have a slide for how to recover from that one because you can't. So this is the private case class thing that was mentioned in the reaction. So what you can have is what I call a write-only ADT. It's write-only because your consumers that use your library can only create values of your ADT, but they can never observe the internal. Once they're created, it's completely opaque from their point of view. But from your point of view, you can pattern match on it, and you will get exhaustivity warning because it is actually sealed. So it's quite useful. Also, I tend to use abstract classes instead of traits for ADTs, but you can use traits as well. It's just that if for some reason you don't want it to be sealed for weird reasons, it's good to have the constructor private. But if the constructor needs to be private, it needs to be a class. So yeah. Okay. The disappearing method. That's my favorite. So you had this method foo, and you don't like it anymore. And you want to get rid of it. So what do? You deprecate it. Is that a backward source compatible change? Add a deprecation? Who thinks it's backward source compatible? Who thinks it's not backward source compatible? Yeah, quite a lot of people actually. It's backward source compatible except for those users who have X fatal warnings in their build, right? And as we know, we all like to use X fatal warnings, right? So yeah, this is not a backward source compatible change, guys. This is going to break people's code. But you know, it's okay because it's binary compatible. What is also binary compatible when you really, really don't want people to use that method anymore? You can make it protected bracket something, for example, the enclosing class. This is really nasty, it's really evil, but it works really well. And this can be useful in some cases when you replace the method by another source syntax that will be kind of mostly source compatible. Like you turned a single parameter thing into a varargs thing or something like this. Or there is an implicit conversion that can fix it, or things like this. But you need to preserve the old binary signature. What you do is you put that protected test thing in a superclass, so they will be inherited, but at the same time won't be seen by ScalaC, so it will be able to compile it without reporting clashes of the source signatures. And then everyone will keep living happy. It will be both binary compatible and kind of source compatible, and you can keep evolving. I've done that. I also advised SBT to do that once. I don't remember when. I'm not sure they did it. Yeah, last thing, privatize, seriously. There is so much public stuff in libraries that should not be public. Really constrain things as much as possible. Because everything that you make public is something that you will have to preserve forever. Remember, if you break it, it's the entire ecosystem goes down. So there is this famous guy from JavaScript who has this slide with I have stopped using this, and I have stopped using classes and prototypes and a bunch of things. So here is what I have stopped using in Scala. I have stopped using result type inference in methods because things happen and the result types suddenly change, and then it's not the same signature at the binary level anymore. I have stopped using default parameters, you guessed it. I have stopped using case classes, unless they're write-only. I have stopped using non-sealed classes and traits. I have stopped using concrete members in open traits. And I have stopped using public APIs. Yeah, remember I'm the author of Scala.js. I had to mention Scala.js somewhere, and Scala Native. So I've been talking about binary compatibility, mostly from a JVM perspective. So what about the other platforms? What happens there? So the thing is, the authors of those other platforms are pretty smart people, and they know that they have to integrate with the rest, with the existing ecosystem of the JVM. So they made sure that whatever was binary compatible for the JVM would also be binary compatible for Scala.js and Scala Native. So basically, you use the same reasonings, you use the same tools, for example, MIMA, and if your thing is binary compatible at the JVM level, it will also be binary compatible at the Scala.js and Scala Native levels. At least it's the theory. Scala.js is pretty mature in that respect. So unless you do JS classes, which is a bit different, but for normal classes in Scala.js, that's how it works. In Scala Native, in the 0.3 series, which is the current release, there is one known bug where this doesn't really work, but it's going to be fixed. It's definitely considered a bug that it doesn't work like on the JVM. So if we follow those principles, and some more that you have to figure out for yourself with experience, how long can you actually maintain binary compatibility this way? Well, I told you earlier, years. Years of backwards binary compatibility is definitely possible. And I'm talking about Scala.js, which has its own compiler with its own binary stuff and the way it compiles things, and it has added language features and big language features over these 3 years, and still we managed to preserve binary compatibility. So as library authors, you can probably survive like 10 years without breaking binary compatibility. So at this point, you can basically outlast the time to live of each major Scala version. What does that mean? Well, remember that a new Scala major version breaks the binary ecosystem, right? So when you introduce a new major Scala version in your cross build, that is the right time to get rid of the things you really want to get rid of for that version of Scala, not for the other ones, because you need to keep the binary compatibility for the other ones. But you can actually get rid of them for the new version of Scala because it's anyway a completely different binary ecosystem. So introducing a binary incompatibility in your library at that point is completely irrelevant because it's anyway shadowed by the binary change in Scala. So this is when you can break binary compatibility, not before. And it's definitely possible. We've done it. So this is what you want to aim for. You want to aim to outlast the Scala major version time to live with your library binary compatibility promises. Yeah, I hear a lot about Tasty. Will Tasty solve this? A bit, mostly no. It also makes some things worse than binary compatibility because some things are binary compatible but not Tasty compatible, just the way that some things are binary compatible but not source compatible. But Tasty will give us more of a binary feeling in the sense that it's possible to make things compatible over time, while at the same time being not so stringent about things like private vars in trades and stuff like this. So Tasty will a bit help, but it will be more of the same, just you will be more empowered at this point. So, very quick summary. Binary compat matters more than source compat. So that's what your version numbers need to reflect. MIMA is essential, but it won't help you if you've already locked yourself down. So you have to learn the compilation scheme to be able to design your things accordingly. And if you also cross-compile to Scala.js and Scala Native, the same reasoning applies. That's it. I'll be happy to take questions for 1 minute.
Oh, there's. I feel like your talk really cemented for me and convinced me that I want to go source dependencies, which was not your goal. Because what I get out of this
Could
is
you
that
just hold them? Yeah,
if everyone does
much
everything
better.
perfectly, then we could achieve a perfect goal. And if one person messes up, it's a disaster for the ecosystem with binary compat. With source compat, we'll never do perfectly, but if someone messes up, it's not too bad. So from a case of minimizing downside, since we've proven we can't do perfectly, we have the spark. Yeah, you talked me out of wanting binary compatibility.
This is an interesting observation. So the thing is, well, if one person messes up, all its dependents are a bit kind of stuck, and you will need a new version of that library, or you will remove that library from history and you will put a new version that fixes the old binary incompatibility, just the way that Scala 2.11.12 did for 2.11, 9 and 10, or 10 and 11 or something. No, yeah, whatever. But with source compatibilities, I'm not exactly sure how we're less of a threat of one person really screwing up, because if there is a new version of that library and it's not source compatible, well, same problem. You don't really know what to do. You're stuck anyway, or you fix it. I'm not quite sure that that it makes things easier. But I would be happy to to discuss more about this.
Another question? No.
Okay then.
Hi.
Hey.
So, do you think Scala should we should make changes in Scala to make it easier to maintain binary compatibility?
Do we need tools to make that easier? Is that the question?
Tools or language changes?
Tools or language changes. Yeah, so one thing I would like to see is these verbose patterns that we have to use to avoid, to enable our libraries to become, to be evolvable. I think those patterns would probably deserve some language support so that we're less tempted to use the shortcuts which exist already and which are actually wrong. Like, I would very much like to see something that gives me the entire desugaring of my option bags pattern, because it's too tempting right now for people to use case classes because it's one line and it does the thing, but it does it wrong. If there was another language feature that allowed me to do that in one line as well, but do it right, that would go a long way into improving our chances of keeping our libraries compatible in that sense. Yeah, that's a good question.
What do you think about when you have some library about prefixing package with the version, like v1, v2, and you can shade? And what do you think about this solution?
This is actually a very good solution when you've reached a point where it's impossible to imagine that you could publish a version that would conflict with the old ones, because you have such a big ecosystem in front of you that is waiting for you to be compatible that there is no way around it. At this point, this is probably the only solution. However, you have to keep in mind that when you do that, if there are parts of the application that use v1 and parts that use v2, they cannot interoperate. They cannot use the data structures from v1 and v2 and talk to each other. So it's not a silver bullet. It has those tensions. So it is a good thing as a last resort when all hope is lost. Then you can use that indeed. Yeah.
Okay, thank you very much for the talk. I think it was.
Thank you as well.